Hello everyone, in this video we'll discuss about the process states in the Linux. The various process states, general process states are like the new, ready, running, waiting, or else the blocked, terminated. So these are the various process states in the Linux. The new is a command which is used for the process is been created, and ready, the process is ready to run and waiting for the CPU allocation. Running, the process instructions are being executed. Waiting or blocked, the process is waiting for an event to occur. Terminated, the process has finished execution. So there are different transition between the process states. So the general stand transitions, new to ready, the condition the process has been created and is being prepared to run. The transition happens after the operating system completes the necessary installations. Ready run, the process scheduler selects the process for the execution. Running and waiting, the condition is like the process needs to wait for an event such as input output completion or a signal. Running ready, the process is permitted typically because its time slice has been expired or highly priority because of the need of the CPU. Waiting to ready, the event, the process was waiting for an occurrence such as the input output completion. Running to terminated, the process has been completed its execution. This transition occurs when the process finishes its final statement and request for the operating system to delete the invoking and exiting system calls. And waiting terminated, the process is forcefully terminated while waiting for an event due to error or an external termination request. New terminated, the process is terminated during its creation phase, typically due to error or resource constraints. Specific to Windows, ready, run or transition, the process is being swapped out of memory. Transition to ready, the process is being swapped back into its memory. Specific for the Linux, running, sleeping, interruptible, the process is waiting for an event and can be interrupted by the signals. Running, sleeping, and uninterruptible, the process is waiting for an uninterruptible event, typically a hardware condition. Sleeping ready, the event, the process was waiting for the occurrence of new process. Running, waiting, and stop, the process is stopped by the receiving signal. Running, waiting, or to zombie, the process has finished execution but the exit status has not been collected. Running, waiting, or dead, the process is in the process of being removed from the system. Transitions and the memory access in Linux, like operating systems, signals notify process of specific events promoting state transitions. These signals can cause process to switch states, such as moving from running to terminated or waiting to ready. Key such as like signal term and kill. Common signals and their effect. Sig stop describes stops pause the process. Transition running to stop, condition sent by a user to or another process to pause the processing execution. Sig count describes the continuous a process that was stopped. Transition stop to ready. Now the process of it is like it starts the process. Condition sent by the user or another process to resume the paused process. Sig term discuss politely ask a process to terminate. Transition running or waiting to terminated, condition sent by user or another process giving the process a chance to clean up before terminating. Sig kill, forcefully terminate a process, which is like running or waiting to terminated. Condition, the process cannot catch or ignores the signal. So this is a process a diagram. So we can see the terminal driver, memory management kernel, another use process, window manager, shell command. So a processor can send different kind of conditions to the different processes to stop or else start or else terminate according to its uh, user commands. Memory access during the process state transitions. Memory management is a crucial aspect of process state transition involving both primary memory and secondary memory, which is called as the RAM or as the disk storage. Here's how primary memory are accessed during these transitions. New to ready primary memory. The process control block and the necessary code or data segments are loaded into the RAM. The operating system allocates a memory space for the process, installing its stack, heap, and data segments. Secondary memory, which is called as a disk storage, the executable file is read from disk storage to load the process into RAM. Read to run, the primary memory, the process is moved from the ready queue in the RAM to the CPU for execution. The CPU cache may load instructions and data from RAM for faster access. For the secondary memory, no direct access. The process runs entirely in the RAM unless it needs to load additional data or code segment from the disk. Running waiting for the primary, the process state and the context are saved in the RAM, so it can be resumed later. Secondary memory, if the process is waiting for input output income, it may involve accessing disk storage to read or write data. For running running to read the for the primary memory, the process state and the context are saved in RAM. The process is moved back into the ready queue in the RAM. For the secondary memory disk storage, if the process was swapped out, it may need to be swapped back into the RAM for the disk. Waiting to ready for the primary memory, the process is moved from the waiting queue to the ready queue in the RAM once the event is waiting for occurs. For secondary memory, if the process was swapped out, it may need to be swapped back into the RAM. To stop up for the primary memory, the process state and the context are saved in the RAM. The process remains in the RAM but not executed. Secondary memory, typically no immediate access to direct disk storage. This process state is maintained in the RAM. Stop to ready primary, for the primary memory, the process state is restored from the RAM and moved to the ready queue. For the secondary memory, no direct access unless the process was swapped out while in the stop state. Running waiting or terminated, for the primary memory, the process is removed from the RAM, freeing up memory space, and the PCB along with the other related memory structures are deallocated. For secondary memory, the process exit status and other necessary information might be returned to disk, and any temporary files created by the process might be deleted. Paging. So when a process needs more memory than available in RAM, the operating system uses paging to transfer portions of the process, like pages, between RAM and secondary storage. A page table in the RAM tracks which pages are currently in RAM and which are on disk. Swapping to free up RAM, the operating systems can swap entire process out to disk, bringing them back into RAM as needed. This process involves transferring the process state, code, and data segment between RAM and secondary storage. Thank you. So in this video, we have discussed about the memory access during the process state transitions, uh, as well as the transitions and the memory access. And we also discussed about the various process states in the Windows as well as Linux. Uh, so thank you so much.